In our mathematics syllabus, we keep facing problems related to congruence of triangles. In fact, there are 4 theorems or 4 rules through the help of which we can prove that the triangles are congruent. And if you want to learn about these rules with the help of animations, you have come to the right place. So let's jump into the video straight away. Hey guys, this is Vikas Sharma welcoming you on behalf of Exponent to Success to yet another video of ours. Exponent to Success is an initiative that helps to add an exponent to your learning curve. If you're new here or if you're landing on our channel pages for the first time today, I would strongly recommend that you subscribe to our channel right now so that you do not miss out on any future content from us. And do not forget to click on the bell notification also so that whenever any new content is uploaded, it comes right into your inbox. In this video, we are going to talk about congruence of triangles. If you don't know what congruence is, let me explain it to you in a very simple way. Suppose you have got a $1 coin here and you take another $1 coin, and if you place this $1 coin over the other dollar coin, they will completely coincide on each other or superimpose on each other, or they will overlap each other, whatever way you want to call it. But when they are on top of one another, they stack up on each other and you can't see one coin below the other. That is what congruence means. Now, congruence is a concept which was introduced to you probably in grade 7. It was used in grade 7 also, grade 8 also, and probably it will continue to be used in the coming grades too. So that is why it is very important that we understand what congruence actually is and what congruence of triangles is. So basically, let's start with the congruence of triangles. Here we have got 2 triangles. Let's call these triangles A, B, C, and probably this triangle I'll name it as X, Y, Z. Now, if we look at these 2 triangles, we can say that they are completely congruent, because if I pick up one triangle, I can pick it up and put it right on top of the other triangle. So if I keep it here, you see it completely overlaps the other triangle. You can't see the blue triangle now, you can see only the red triangle because it has completely superimposed. And if you noticed, all the side lines, they are the same, all the angles, they are the same. So let's consider what these are. So whenever we say that 2 triangles are congruent, it means that all their corresponding sides should be equal. For example, if we talk about these 2 triangles, then it simply means that AB is equal to XY, because they are the corresponding sides in these triangles. We talk about BC is equal to YZ, being the corresponding sides in both the triangles, and AC is the same as XZ. And we can talk about the angles also, that angle A is equal to or is congruent to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. So in any 2 triangles, we have these 6 parts which are completely the same as each other. That is when we can say that the 2 figures are congruent. But at the same time, we do not need to know all these 6. Even if we know 3 of them, it's enough to say whether the figures are congruent or not. Let us take another example about congruence of triangles. Here I've got again 2 triangles. Let me again name them A, B, C, and let me call this D, E, F. Now what can we say about the congruence of these figures? Do they look similar? Do they look congruent? Well, let's see. If we can rotate one of the figures and put it on top of the other, and in case they completely overlap, then we can say that they are congruent, otherwise they will not be congruent. So let's see if we can rotate it, put it on top of the other, and then see if they can be congruent. So let me rotate first. Still doesn't look the same. Rotate more, still doesn't look the same. Let's rotate a couple of more times. So let's rotate one more time and see. Yes, now they appear to be congruent. And if I can pick up one figure and put it on top of the other and it completely overlaps, then we can say that the figures are congruent. So yes, this is a congruent figure as we can see here. But let's bring it back to the previous position. This is how it was. And let's see how the triangles are. So in the first case, if I show you, if these two figures were congruent, we can say that triangle ABC is congruent to, so usually we have a symbol for congruence, which is an equal to sign, and on top of that we have this. So whenever you see this figure, it means is congruent to triangle XYZ. Now here, if you look at it, it is very important to name the triangles right, or so that whenever you see a corresponding side, so if you see AB and if you see XY in this triangle, we come to know from the naming of the triangle that AB is the corresponding side as XY in both the triangles. Or in both the triangles, if we look at the side BC and YZ, they should be corresponding sides. And if we look at AC and XZ, they should be corresponding sides. Similarly, angle A corresponds to angle X, angle B corresponds to angle Y, and angle C corresponds to angle Z. Now, using this naming convention, what can we say about these two triangles? Well, ABC is congruent to DEF, but let us see which are the corresponding sides. So when we rotated the figure, we found that this side was equal to this side, and that this side was equal to this side, and that this side was equal to this side. So if we look at the corresponding sides, side AB corresponds to side FE. So we can say that triangle ABC is congruent to triangle FE, and BC corresponds to side ED. So BC should correspond to ED, and therefore we can say that AC corresponds to side FD or DF. So this is what congruence means. And whenever we are talking of congruence of triangles or congruent triangles, there are some theorems related to that. There are some axioms also. So let us learn about those, what they actually mean. How can we prove that two triangles are congruent to each other? But before we go further, let me explain a few things to you. So let us understand what an axiom is. Now, axiom is something which does not need to be proved. It is by conclusion. You can always say that it is true. And why is that true? Let's say that we have a line segment and we have another line segment. They meet each other at a point, at a certain point, and obviously when they meet each other at a certain point, they make a certain angle between themselves. Now if we know that this side is say x centimeter, and we say that this side is y centimeter, and if we take another two lines again of the same length and making the same angle between them, and let's say this is x centimeter and this is y centimeter, then no matter what you do, if you want to make a triangle of it, you will have to join this side to this side. There is no other way of going about it. And if the distance between these 2 points is going to be the same always, because the distance between two same points or congruent points which are equidistant from each other, they will always remain the same, then by conclusion we can say that this side will be equal to this side. So that means if two sides of an angle of a triangle are given and the angle between them is given, so it is called the included angle, the angle lying between the two sides. So this is one side of a triangle, this is the other side, then the angle they form between them is called the included angle. So when two sides of a triangle are equal and the included angle between them is equal, it's called the SSS congruence rule. Now let us understand what the SSS congruence rule says. It says that if two sides and the included angle of one triangle are equal to the corresponding sides and angle of another triangle, the triangles are said to be congruent. Let's understand with a few more examples what SSS congruence rule means. So here we have got two triangles. So in these two triangles, which are triangle ABC and triangle NDE, we know that side AB is the same as side DE, which means they are equal. Side BC is the same as side EN, which means they are equal, and the angle between them is 57.57 degrees. That means if we rotate this triangle, it will completely overlap over the other triangle. Let's try and see if we can do that. Let's take it over here. And you see that this triangle completely overlaps the other triangle. Therefore, we can say that both the triangles are congruent. Now, let us see what we can say about the congruence condition or the naming of the triangle. What can we say about this? That means we can say that triangle ABC is congruent to. Now we have to look at the corresponding side. So if we look at AB 4.9 centimeters, that's the same as NE. So we can say is congruent to triangle NE, and then we have the angle there and BC. So here it's ED. So we can say that triangle ABC is congruent to triangle NED. Will this always be the case? Well, let's see another triangle. So if I just move this triangle a little bit, I've made both the triangles in such a way that if I move one side, the other triangle will always change. So you see again that the side lengths here 7.26 and 7.26 and 4.84, 4.84, they are the same, and the angle included is also the same, which is 27.08 degrees. Now let's try and rotate this and see if we can make any sense out of it. So yes, we change the triangle and then again it completely overlaps over the other. Let's take another condition, another triangle. So how about this, that the angle included is 104.65 degrees, one side is 4.6 and the other is 4.84. Let's see if this meets our condition. Yes, this also completely superimposes over the other triangle. So that means every triangle which has got two sides equal and the included angle equal between them will always be congruent to each other. But what happens when we have got two sides equal? So here we have got two triangles, 3.74, 3.74 is one of the sides, 6.94, 6.94 is the other side in both the triangles. One angle is 29.86 degrees, one angle is 29.86 degrees. But do they look congruent? No, one seems bigger than the other, even though two sides and one angle is the same. They are not congruent. And why are they not congruent? That is because the angle between them, in this triangle the angle is the included angle, and in this triangle the angle is not the included angle. So when the angle is not the included angle, then we can say that these triangles are not congruent to each other. Now the second condition of congruence, so we have learned about the SSS congruency rule, which is the number one criteria. The second criteria is that if two triangles, which is called the SSS congruency rule, and if we look at an example of that, we can say that if two triangles have all sides equal, then they can be said to be congruent to each other. Now how is this true? Let's look at these two triangles ABC and triangle FDE. Here we can see one side is 6.68, in the other triangle also one side is 6.68, one side in this triangle is 7.89, and so is that there in the other triangle, and 7.64, 7.64, they are the same. Now can we say that they are congruent to each other? Let's rotate the figures and see if they are congruent. So let me rotate this triangle this way, and we just drag this point and keep it on top of the other, and a little bit of adjustment here. And when we do the adjustment, we find that one triangle completely overlaps the other. That means if three sides of a triangle are corresponding sides, if they are equal to each other, then we can say that the triangles are congruent to each other. Let's bring the triangles back to their original shape. Let's change the triangle. So we have got these two triangles now. Again, you see all the three sides are equal: 7.89, 7.89, 3.3, 3.3, 6.58, 6.58. Let's again rotate the figures and see if we can get them to be congruent to each other. Yes, they completely overlap each other. So these two triangles are also congruent. Let's take another triangle. How about something like this? Well, let's rotate this and see if they are congruent. Let's bring it on top of this, adjust it here, and we see they again superimpose over each other. That means that whenever we have two triangles in which all sides are equal, those triangles are said to be congruent to each other. This is called the SSS congruence condition. Let us learn about the naming of the triangles again. So here we've got triangle ABC that is congruent to. Now in congruence we have to remember that the sides have to be the corresponding sides. So AB is 5.75 centimeter and next is the 7.89. So here we'll start from EF, which is 5.75, and then we go to 7.89. So this should be congruent to triangle EFD. So you can't say that triangle ABC is congruent to triangle DEF, because then the corresponding sides will not be equal. So even though we have taken three conditions here, we don't know what the angles are. We just know the three sides. If they are equal to each other, we can say that the triangles are congruent to each other. Let's see what the SSS theorem of congruency say. It says that if three sides of one triangle are equal to three sides of another triangle, the triangles are said to be congruent. So that's the SSS rule of congruency. Let's go to the third rule of congruency, which is called the ASA congruency. ASA means if two angles and the included side, they are equal, then the triangles will be congruent to each other. But in this case, I want to draw your attention to the fact that it is not necessary that we have an ASA congruency only. Even if we have AAS or SAA, then also we can say that the triangles are equal or congruent. The side does not have to be the included side here. So here we have got two triangles in which one angle is 47.72 in both the triangles, the other angle is 31.57 in both the triangles. One side of both the triangles is 5.32 units, which is equal, but it is not the included side. Now let's see if this will work. If we can overlap the figures and see if one triangle sits on top of the other. Let's see if we can move the figure around and put it on top of the other to see if it overlaps or not. So let me rotate the figure a little so that it starts looking like that. Then I take this and place it on top of the other like this, and then do a little bit of adjustment here. And yes, you can't see the brown triangle anymore. All you can see is red. That means they are completely overlapping each other. That means these two triangles are congruent to each other. Okay, now let's see what we can say if we change the triangle a bit. So what if we have a triangle like this? Here, let's again try and rotate the figure and see if we can place it on top of that. Yes, they are congruent. So what can we call this? Like I said, this is called the ASA congruency rule, or even if we take it as SAA or AAS congruency, then also it is fine. Let us see what the theorem says about it. So the theorem says that if two angles and the included side of one triangle are equal to the corresponding angles and side of another triangle, the triangles are congruent. But this does not mean that it has to be included side only. So we can say it in another way also, that if two angles and the non-included side of one triangle are equal to the corresponding angles and side of another triangle, the triangles are said to be congruent to each other. We have one more rule for congruency, and that is called the RHS rule for congruency, in which we are looking at only right angle triangles. So RHS stands for, R stands for right, H stands for hypotenuse, and S stands for side. So this rule says that if in a right angle triangle the hypotenuses are the same and one of the sides of the triangles are same, then we can say that the triangles are congruent to each other. Like we have these two triangles here. Let's see whether they're congruent to each other. Both are 90 degrees angles. Now one of the sides is the hypotenuse is 5.99 in both of them. One side is 5.6 and so is the other in the other triangle. Please notice that the 90-degree angle is not the included angle here. So we looked at the SAS condition where it had to be the included angle, but in this case it is not the included angle. And let's see if the triangles are congruent or not. So if I just rotate this figure a little, make it look like this, drag it on top of that, do a little bit of adjustment here, and it completely overlaps the other. So we see that these two triangles are congruent to each other. What if we change the figure a little? What if we take a triangle like this? Will they still be congruent to each other? Let's see. Rotate it here. Drag it here on top of this. Do a little bit of adjustment here. And voila, they are again congruent to each other. Let's look at a third example. What about this triangle? Are they congruent? Will they be equal to each other? Let's see. So I rotate it like this, bring this on top of this, adjust it here, and yes, they are congruent to each other. That means if the hypotenuse of a right angle triangle, if they are the same, and one of the other sides of the two triangles, if they are the same and the angle is a 90-degree angle or a right angle, then we can say that the triangles are congruent to each other. This is called the RHS rule of congruency. Here, if we talk about the naming condition, let's see what that says, that we have triangle BCA. That should be congruent to. So BC is 6.77. Here we have triangle EF, which is 6.77. And then we have an unmarked side, and so is it here. So EFD. In both cases, angle A is 90 degrees in the first triangle, and so is angle D in the second triangle. So RHS condition also works. If we look at the RHS theorem, what does the RHS congruency rule say? Or what does the RHS congruency rule say? Or what does the RHS theorem say? Let's have a look. It says that if the hypotenuse and one leg of one right angle triangle are equal to the corresponding hypotenuse and leg of another right angle triangle, then the triangles are said to be congruent to each other. Now we've seen all these congruency conditions, but you must be thinking there should be one more. Are we missing something? Should there be a condition like say AAA? What about, like we said, we need only three of the things. If they are equal, we can say that the triangles are equal to each other. What if we look at the AAA congruency? Or is there a rule which is called the AAA congruency? Let's have a look at some of the examples that we have. So these are two triangles that we have in which all the three angles, they are congruent to each other or equal to each other. So here you can see that angle A is equal to angle B, angle B is equal to angle D, and angle C here is equal to angle E. But are they congruent? Well, no, they don't look to be congruent because one is much bigger than the other. So even if we drag it and keep it on top of that, it will not overlap or superimpose on the other. What if I make it like this? Still the three angles are the same, they are equal. But if we drag one over the other, will it superimpose? It will completely cover the other. The sides will not superimpose on each other. So that's why the AAA congruency condition does not hold. There is no rule called the AAA congruency rule or no theorem which says that if three angles of two triangles are equal, then the triangles have to be corresponding to each other. Well, if you go to the next grade, you will learn about similar triangles in which there is a condition that if three angles of a triangle are equal to each other, then they are said to be similar. And if I've in fact made a video on similar triangles also, and if you want to have a look at one such video, just click on the top right corner of the screen and you'll be taken to the video straight away. So that brings us to an end of the video. I hope you enjoyed the video thoroughly and you learned something useful out of it. In case you did, I would like to hear all about it. So just head down to the comment section below and leave in your comments for me. In case you are facing any problems with any of your questions, or in case you want me to cover any specific topic, just mention that in the comment section too and I'll surely get back to you with a video. I would surely recommend that you hit on the like button below and share the video link with your friends so that they also learn something useful out of it. And in case you haven't subscribed to our channel as yet, this is the right time to do so. You see a subscribe button right in the center of the screen. Just click on that and you'll be subscribed to our channel straight away. And do not forget to click on the bell notification also so that any future content is delivered right into your inbox. As a part of your continued learning, you can click on these videos shown on the left side here. Please like and share the video. Take care. God bless.